These are the examples from lesson 5.2. Example 1, we are to determine whether x is a binomial random variable. All right, part A. A fair die is rolled 20 times. Let x be the number of times the die comes out to be a 6. Okay, the first thing we need is we need to know if there are a fixed number of trials. And yes, there are. Our fixed number is right here. That's 20. All right, the next thing we want to know, are there 2 possible outcomes for each trial? Well, yes. Either we get a 6 or we don't get a 6. Okay. Number 3, is the probability of success the same on each trial? Well, the probability of getting a 6 is always going to be 1 out of 6, so yes. All right. Are the trials independent? Does rolling a 6 the first time affect rolling a 6 the next time? No. So yes, they are independent. So for part A, yes, we do have a binomial random variable. Okay, the next one. A standard deck of 52 cards contains 4 aces. 4 cards are dealt without replacement from the deck. Let x be the number that are aces. Okay, all right, first thing. Do we have a fixed number of trials? We do. And right here it is, 4. We are dealing out 4 cards. All right. Do we have 2 possible outcomes? Yes, we do. We get an ace or we don't get an ace. Number 3, is the probability of success the same on each trial? No. And the reason it's not the same is because we're dealing out 4 cards. So when we deal out the first card, the probability of getting an ace is 4 out of 52. Then the next card is going to be out of 51 because we've already dealt 1 card out here. Now we don't know whether we have an ace or not, but it doesn't matter what goes up here. Sample space is decreasing. And then when we get our third card, there's only 50 cards left to choose from, and then there's only 49 cards to choose from that last time there. So the probability is changing. This is not going to be a binomial random variable. Okay, B. We got a sample of 50 voters drawn from the residents in a large city. Now, this word right here is kind of relative. So if we think about large, we'd probably be thinking about, I don't know, maybe about 50,000 people. So I'm just going to put 50,000 over here. We're going to let X be the number who plan to vote for a proposition to increase spending on public schools. All right, are there a fixed number of trials? Yes, there are. We've got 50 voters. Okay. Are there 2 possible outcomes for each trial? Yes. Either we're going to vote for the proposition or we're not going to vote for the proposition. All right. Is the probability of success the same on each trial? Absolutely. There's a 50% chance. We can either vote for it or we can vote against it. Those are our only 2 options. Are the trials independent? Well, that goes over to here. When we have a simple random sample and it is less than 5% of the population, then yes, the sampled individuals are independent. So what we need to do is we need to figure out 50 is 5% of what number? All right, so we said we thought a large city would be about 50,000 people. All right, let's see, 50 over x equal to 5 over 100. And if we cross multiply, we have 5x equal to 5,000. So x is going to be equal to 1,000. So 50 would be 5% of a town that had 1,000 people in it. But remember, we said 50,000 was large. So I would say that yes, these are independent. The the voters are going to be considered to be independent samples, or from an independent sample. So yes, we do have a binomial random variable here. Example 2. In June 2009, 20% of video gamers had heard of the game Modern Warfare 2. The data is from GamesBeat. Assume that 18 gamers are randomly sampled. A. Use a binomial probability distribution to compute the probability that exactly 4 of them have heard of Modern Warfare 2. All right, let's look at the things that we know. Our fixed number of trials is going to be 18 because we're talking to 18 gamers. The probability of success, these would be the people who have actually heard of this game. This is going to be 0.20. And then the number of successes we want, down here it says exactly 4, so we want 4. All right, and now if we want to find the probability of having exactly 4 people who have heard of this game, we are going to do a combination of 18 things, taken 4 at the time, times the probability of success, which is 0.20, raised to the power of 4, because we wanted 4 successes, times the probability of failure, this is 1 minus our probability of success, raised to the power of the number of failures. Now, if we had 4 successes and 18 total, then our power is going to be 18 minus 4 here. And we should be able to put this into the calculator. So let's see. All right, so 18 things taken 4 at the time. This is going to be 3,060. And 0.2 to the 4th power is going to be 0.0016. And then 1 minus 0.2 to the 18 minus 4 power, this is going to be 0.440. And this is after we did some rounding. And then we can put all that in the calculator to get our final answer. And this is going to give me 0.215 after I've rounded it off. Okay, B. Using table A1 to find the probability that fewer than 3 have heard of Modern Warfare 2. Now, fewer than 3 means that we could have none of them who have heard of Modern Warfare 2, just one of them, or 2 of them who have heard of Modern Warfare 2. So what we're going to do is we're going to find the probability that nobody's heard of it, and we're going to add that to the probability that exactly 1 person has heard of it, and we're going to add that to the probability that exactly 2 people have heard of it. And we're going to do this using table A1, which there's a link to it over in Blackboard under the Tables tab on the left over there. All right, so what we have here is we've got our table of the binomial probabilities. Here's the formula. It's written in a totally different way from the way that it's written in the textbook in this particular lesson. The first column here is N. This is our number of trials, and you'll notice some of the lines are skipped. Okay, that's on purpose because they have to list in the next column X the number of successes. And notice the number of successes goes up to whatever N was. And so it goes up to 3 because N was 3. This one goes up to 4 because N was 4. And this table will go all the way up to 20. Okay. Across the top, they have some sample probabilities written. So this won't work for every single probability problem that you have, but it'll work for some of them. And these are some common ones up here on the top. Now we should be looking in this column right here, the 0.2 column. And we've got to go down. Let's see, that's the third one. We've got to go all the way down to where N is equal to 18. 13, 14, 15, 16, we're almost there, 17, 18. All right, and remember, we're supposed to be looking for the probability that 0 people have heard of this, the probability of 1, and the probability of 2. So if N is equal to 18, there's 0, 1, and 2. and the 0.2 probability was the third column. That means we're going to be adding together. I just lost my chart there. The 0.018, the 0.081, and the 0.172. I have listed those probabilities right here under x equals 0, x equals 1, and x equals 2. Now all we need to do is put this in the calculator and add them together. And this is going to give me 0.271. All right, C. Find the probability that more than 3 of them have heard of Modern Warfare 2. Now, more than 3. This is the probability that x could be 4, x could be 5, x could be 6, could be 7, could be 8, could be 9, all the way up to 18. Now that's an awful lot of numbers to look up, and it's an awful lot of times to use this formula right here. So what we can do instead is we can use the complement. Now the complement of more than 3 is less than or equal to 3. So what I'm going to do is I'm going to find what I don't want, which is 3 have heard of it, 2 have heard of it, 1 have heard of it, or none have heard of it. And then I'm going to subtract 1 using the complement. And that's going to look like this. We're going to have 1 minus the probability that x is equal to 0 or 1 or 2 or 3. And I'm going to go back and I'm going to refer to my table again. Now remember, I already have this probability right here. I just found it. It's 0.271. So we're going to have 1 minus 0.271, and all I need to do is figure out what the probability that 3 people have heard of this. All right, so let's see. I'm looking over here at 3. Let's see if we can move this guy over. Okay. 3, that's 0.230. Alright, and now I can put this in my calculator, and I will get 0.499. Okay, now, D says to find the probability that the number who have heard of Modern Warfare 2 is between 2 and 6, and it is inclusive. That means we're including the numbers 2 and 6. So what I'm looking for here is the probability that x is equal to 2 or 3 or 4 or 5 or 6. And I can do this over in the table as well. Now 2 and 3 I've already found. 2 is 0.172 and 3 is 0.230. And now I'm going to go get 4, 5, and 6 out of the table. 4 is 0.215 and 5 is 0.151 and 6 is 0.082. And if we put all this in our calculator and add it together, we're going to get 0.85. Example 3. The name of Modern Warfare 2 was originally planned to be Call of Duty Modern Warfare 2. In June 2009, 40% of gamers had heard of Call of Duty Modern Warfare 2. The data comes from GamesBeat. Assume that 12 gamers are randomly sampled. A. Compute the probability that exactly 7 of them have heard of Call of Duty Modern Warfare 2. Okay, things we know. The number of trials we have this time is 12 because we are going to be talking to 12 gamers. The probability of success, these are the ones who have heard of the game. Right here it is, 40%. And the number of successes I want tells me right here we want exactly 7 of them. And I think I'm going to use my formula again instead of using the table. I can use the table on this one and it'll be really quick. But I'm going to put this into the formula just to get practice with using it. All right, so the probability that exactly 7 people have heard of this game is going to be 12 things taken 7 at a time times our probability of success, which is 0.4, raised to the power of the number of successes we want, times our probability of failure, which is 1 minus our probability of success, raised to the power of the number of failures that we want to have, which will be our total minus our number of successes. Okay, let's put this in the calculator and see what we can get. All right, 12 things taken 7 at a time is going to give me 792. And then 0.4 raised to the 7th power, this is going to be 0.0016 when I round it. And then our probability of failure, we're going to do 0.6 to the 5th power here. This is going to be 0.0778 when we round that one off. All right, and let's multiply all this in the calculator. All right, so if we use our rounded numbers, we're not going to get quite the right answer. We are supposed to get 0.1009. So be sure when you're working these, if you're using the formula, don't use your rounded decimals. Wait until the very end down here to round your answers off. Okay, part B. We're supposed to find the probability that fewer than 5 of them have heard of Call of Duty Modern Warfare 2. Okay, now let's remember what fewer than 5 means. That means we want the probability that X is going to be 0, 1, 2, 3, or 4. So I've got 5 numbers I can look up in my table and then I can add them together. Or, well, we could use the complement on this, but we'll end up looking up more numbers in the table that way. So it's probably best to go from this direction and just add the probability of 0 plus the probability of 1 and so on. All right, so let's go check out the table and see what each of these probabilities individually is. Here I have listed each of the individual probabilities. I went to n is equal to 12 and then x is equal to 0 to get the 0.002. And then x is equal to 1 to get the 0.017, x is equal to 2 to get the 0.064, x is equal to 3 to get the 0.142, and x is equal to 4 to get the 0.213. So let's put these in our calculator and see what we get. And this will give me a sum of 0.438. Now, C is asking us to find the probability that more than 6 of them have heard of Call of Duty Modern Warfare 2. This is the probability that 7 have heard of them, or that 8 have heard of them, or 9, or 10, or 11, or 12. And so we may want to use our complement on this, which would be 1 minus the probability of zeros heard of it, 1, 2, 3, 4, or 5. We should have put the 6 in here. Well, it says more than 6, so we need to put the 6 in here. Okay, let's put that 6 in right there. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So we'll have to look up a little bit fewer numbers if we went this way with it. However, we already have the probability that x is equal to 0, 1, 2, 3, or 4. So really all I need to do is look up the probability that x is equal to 5, or the probability that, and the probability that x is equal to 6. Okay, so let's see. This is going to give me, all right, so let's find us some place where we got some space to work. Right in here. All right, so we're going to have 1 minus, let's see, the probability from 0 to 4 we just said was 0.438. Now I'm going to look up the probability that x is equal to 5 and the probability that x is equal to 6 in my chart. The probability of exactly 5 is 0.227 and the probability of exactly 6 is 0.177. So let's put all this in the calculator and see what the probability is going to be. And I'm getting 0.158. Okay. All right, part D down here, find the probability that the number you have heard of Call to Duty Modern Warfare 2 is between 3 and 5 inclusive. So we're looking at the probability that x is equal to 3 or 4 or 5. So I'm going to look up and find the probability that x is equal to 3. Well, actually, I already have all these up here, don't I? Let's see. There's 0, 1, 2. So x equals 3. This was 0.142. All right. And then for 4, this was 0.213. And then for 5, we just found that out to be 0.227. All right, so let's put all these in the calculator and see what we get. And this is giving me 0.582. Example 4. Gregor Mendel discovered the basic laws of heredity by studying pea plants. In one experiment, he produced plants whose parent plants contained genes for both green and yellow pods. Mendel's theory states that the offspring of two such parents has the probability 0.75 of having green pods. Assume that 80 such plants are produced. Find the mean number of plants that have green pods. Okay, let's look at the things that we know. Our number of trials is 80, and our probability of success is 0.75. Now, if we want to find the mean, which is mu x, remember the formula is n times p. Well, n is 80, and p is 0.75. So if we put this into our handy-dandy calculator, that's going to give us 60. So the mean is 60. All right, now we want to find the variance of the number of plants that have green pods. All right, let's do that up here where we have a little bit of room there. All right, so the variance is n times p times 1 minus p. This is our formula. All right, so that means we're going to have 80 times 0.75 times 1 minus 0.75. All right, let's put that in our calculator and see what we get. And this is going to give us 15 for the variance. And then for C, find the standard deviation of the number of plants that have green pods. Well, the standard deviation, that's just the square root of our variance. And we just found the variance to be 15, so we need the square root of 15, and let's round it to 3 places. And that will give us 3.873.